Yes. In one of my last video, I made a discussion on the general steps which were involved in the isolation or the extraction of metal from a respective ore. But in this video, I would like to discuss the concept that is what the extraction of a metal like nickel from the ore of the nickel, that is what pentlandite. Pentlandite ore. This is what the discussion what we have as per this class is concerned. For the extraction of any metal from any respective ore, we need to follow the principles and the procedures of the metallurgy. Right? In this class, we have to discuss what are the steps involved in the extraction of nickel from pentlandite ore. Right? Before going to the actual step which are involved in the extraction of that nickel, we will let you know about the pentlandite ore. This pentlandite ore is a sulfide ore generally. Right? It is a sulfide ore, right? Which containing your nickel, copper, and that of iron, and that is it is represented by this. This is what the representation of the pentlandite ore. Right? From this, we have to extract the nickel by keeping the principles and the procedure of the metallurgy. Right? Now, we will know which are the steps involved in the extraction of nickel from this ore. And the first step, crushing and concentration. This is the first step which is involved in the extraction of a nickel from a pentlandite ore. Right? Not only extraction of nickel from pentlandite ore, for the extraction of any metal from any respective ore, the first step what we have to follow is crushing. You have a ore in your hand. First you have to make that into a fine powder form. Right? For any ore, you have to do this process. And as I told earlier in my previous video, if you have a ore, that you have to convert it into a fine powder form. Fine powder form. That was done by what? The big jaw crushers. The big jaw crushers or the ball mills or the stone mills. These are the machines which we are going to making use to convert a ore into a fine powder form. And that process what I told in the earlier class, that is pulverization. The process is what we know as pulverization. Pulverization is a process where you are going to convert the ore into a fine powder form by using the machines like big jaw crushers, ball mills, and stone mills. Right? After crushing, you have a crushed ore. After that, what you have to do? Concentration. Why you have to do concentration? The ore particles are generally associated with the earthy particles, as I told earlier. Right? That may be mud particles, stone particles, any andesite materials. So you have to remove that andesite materials. That was done by concentration. And we have physical method and chemical method for the concentration. Especially these sulfide ores. The sulfide ores are generally concentrated by a physical method which is known as flotation process. The sulfide ores are not concentrated by hydraulic separation. Sulfide ores are not concentrated by magnetic separation. But it was the concentration of that sulfide ores can be done by flotation process. The concentration was done by flotation process, where you are going to making use of water and of pine oil. These are the constituents what you are going to making use in that flotation process just to concentrate the sulfide ores. Right? Just to remove the gangue particles. Right? Whenever, especially in flotation, you are going to take a water in a container. To that you are going to add ore particles along with pine oil. When you are going to add ore particles along with pine oil, the ore particles gets wetted with that pine oil and they are going to float on the surface. When you agitate that mixture, when you agitate that solution, or when you agitate that system, the froth is developed, and that froth containing your minerals. And the impurities which are associated with that ore are going to settle at the bottom of the tank or bottom of the container. Thereby, you will achieve what? You will become successful in removing the gangue particles. And you are going to skim off the mineral froth. And later you will get the mineral particles, or you can say that ore particles from the froth. This is what the method for the concentration of your sulfide ores. And this is about your first step. And the second step what we have to do in this is roasting. We have roasting. Roasting is the second step as per the extraction of nickel is concerned. And roasting, why we have to roast the metal? Why we have to roast this concentrated ore? Especially as I told earlier, the sulfide, it is a sulfide ore. Just to reduce the sulfur content in that ore, I will then roasting. When you roast the ore, roasting is nothing but you are going to heat the ore material or the concentrated ore in the presence of oxygen or in the presence of air. When you heat the ore in the presence of oxygen, here your sulfur gets oxidized into oxygen. For example, in this you have nickel sulfide, you have iron sulfide, you have copper sulfide. These are the sulfides of metals what we are going to observe in Pentlandite. And included that we have a sulfur. So to remove the sulfur, I have to roast. In that roast, I am going to heat this sulfur in the presence of I am going to heat this Pentlandite ore in the presence of air. What happens? Here your iron sulfide heated. When you heat this Pentlandite ore, here iron sulfide gets oxidized into iron oxide and sulfur dioxide. And your sulfur gets combines with oxygen, will lead to the formation of sulfur dioxide. In this case, you will observe that the sulfur content of iron sulfide gets converted into sulfur dioxide. Here the sulfur gets converted into sulfur dioxide. Thereby, a small quantity of sulfur is removed during roasting. During roasting process, a small quantity of sulfur is removed, and we are left with what? Iron oxide. Here, one thing you have to mention, remember that your nickel sulfide and your copper sulfides remains unaffected. That means this nickel sulfide and copper sulfides are not affected by your roasting process. Only your iron sulfide gets converted into iron oxide, and your sulfur gets converted into sulfur dioxide. These are the only two reactions what you are going to observe in roasting. But your nickel sulfide and copper sulfide remains unaffected. This is what you have to remember. Right? After roasting, you are left with what? Roasted ore, which contains nickel sulfide, copper sulfide, and your iron oxide. Here sulfur dioxide is removed. Now come to discuss the third step of your extraction concept. And the third step what we have that is smelting. Now what is smelting? Smelting is one of the extractive method, or it is one of the step of metallurgy where you are going to use heat and some reducing agent to just convert other elements. For example, here we have iron oxide. I don't need this iron oxide, so I have to convert this iron oxide to some form, just to remove the iron oxide. This is iron oxide. I can't be able to remove this iron oxide as iron oxide. I have to convert that into another form. That is what is in the formation of slag. I can able to remove this iron oxide in the formation of slag, in the form of slag. That was done by smelting process. Now, what you are going to do in smelting? You are going to take a roasted ore in a small blast furnace. This is a small blast furnace. Blast furnace is nothing but you know about the shape of the blast furnace. This is what the shape of the blast furnace. And to this blast furnace, you are going to take the roasted ore. Along with that, I am going to take constituents like coke, which is reducing agent, and I am going to take a small amount of lime, and amount of quartz. Why I have to take coke, lime, and quartz? I have an iron oxide. This is what the iron oxide, what I get after roasting. But some iron sulfides, some iron sulfides also gets converted into Fe2O3. Now, I will make use of this coke. This Fe2O3 can be reduced by coke to FeO plus CO2. FeO plus CO2. This FeO, that means all FeO, all iron oxides or ferrous oxide which are formed in roasting combines with silica will lead to the formation of iron silicate. This is what iron silicate, and this is called as slag. And this was impurity. You have to consider this as impurity. That means why I have to consider this iron oxide as an impurity? Since I don't need this. I need nickel from the Pentlandite ore. That's why I am considering this as an impurity. So this impurity I can't able to remove as an iron oxide. That's why I am going to make use of silica. This silica is what we know as flux. And then what do you mean by that flux? Flux is a substance. This is a substance. This substance will combine with the impurity in smelting process. In smelting process to form a fusible slag. This is what a fusible slag, which can be easily skimmed off when compared to your impurity. This impurity is not easily skimmed off. That's why I am going to convert this into a fusible slag by using some substance in a smelting process, and that substance is what is known as flux. In this case, your quartz or SiO2 acts as a flux, which combines with impurity like FeO to form iron silicate. Then what is the use of your lime? That is what calcium carbonate. What is the use of your calcium carbonate? If you take excess of SiO2, you are left with SiO2. If you take excess of SiO2, you are left with SiO2. This is SiO2. This is SiO2, which you are taken as excess. It is left after the reaction. After all, conversion of all FeO will be done. But you are left with SiO2. So I have to remove this SiO2. This is an impurity for me at this situation. Now, for this situation, this is an impurity. So to remove this impurity, I will make use of calcium carbonate. This calcium carbonate, when heated, it will convert into calcium dioxide and calcium oxide and carbon dioxide. Here, this calcium oxide will act as a flux. This calcium oxide will act as a flux to form a fusible slag. That is what calcium silicate. This is what slag, a fusible slag. Here, this calcium oxide will act as a flux to remove the impurity silicon dioxide or a quartz, which is a formation of calcium silicates. These are the two slags which are produced or which are formed during what? Smelting process. Now, generally slags are very lighter in weight. The slags which are formed here is iron silicate and calcium silicate. Your iron silicate and that of your calcium silicate are lighter in weight. They are lighter in weight, and they are going to float on what? The surface of the blast furnace. And we are apart from that, we have left with an heavier material or heavier mass at the bottom of the blast furnace, and that is what called as matte. And the heavier mass which is present at the bottom of the blast furnace after smelting process is what we know as matte, and that matte consisting of nickel sulfate, copper sulfate, and a little amount of iron sulfate. After smelting process also we are left with ferrous sulfate. We are left with iron sulfate. That means this is the iron sulfate which is escaped from roasting process, which is escaped from your smelting process. Now we have a situation that I have to remove this iron sulfide. It is escaped from smelting and roasting. Then what is the other strategy I have to take to remove that? And for that we have a process, and that is what? Bessemerization. In Bessemerization, I can able to remove this iron sulfide, and this is what your fourth step as per extraction of this nickel concern. In fourth step will involve Bessemerization. In Bessemerization, you are going to take this molten matte in a Bessemer converter. And what do you mean by that Bessemer converter? No, Bessemer converter or generally it is a pear-shaped converter, like blast furnace. Like blast furnace, it is a pear-shaped converter. How it is so? This is what the pear-shaped converter. This is what the shape of the Bessemer converter. To this Bessemer converter, I am going to take the molten metal. Especially, this is made up of steel. It is made up of steel, and inside it is lined by a refractory material, and that is what magnesium oxide. This is what refractory material. And what do you mean by that refractory material? What is the use of that refractory material? No, refractory material is a material which is resistant to high temperature, high pressure. They do not. That means that remains as it is. They do not change for high temperature. That's why that is called refractory material. Those materials are what we know as refractory materials. Including that magnesium oxide, we have calcium oxide, which is also known as refractory material. Right? Refractory material is the part which is resistant to high temperature. Into this Bessemer converter, I am going to take the molten matte. To that matte, I am going to blast a sand. Sand plus air. I am going to blast some amount of sand, and I am going to blow air. When you are going to blow air, of course your iron sulfide at high temperature will oxidize it to iron oxide, and your iron oxide will combine with sand. Sand is nothing but silica, right? Silica will give you FeSiO3. Howda? Now, this SiO3 is a fusible slag. This fusible slag can be easily skimmed off. Now, after Bessemerization process, that is almost all amount of iron sulfide is skimmed off or removed by several processes, by several principles of metallurgy. Now, you are left with nickel sulfide and copper sulfide. And now when you see the composition of your nickel, copper and sulfur after Bessemerization, that about 55% of nickel you have, about 30% of copper you have, and about 14% of sulfur you have, and thus less than 1%. Less than 1% you have iron. It is very low quantity. It is very low quantity. That's why we are neglecting that iron. We are concentrating only on nickel. Now you have the mixture of nickel sulfide and copper sulfide. After Bessemerization, the matte what you get is containing this, and this is what we call Bessemerized matte. Bessemerized matte. This is what we call as Bessemerized matte. Now you have successful in removing the iron sulfide. Now we are left with nickel sulfide and copper sulfide. So I have to remove, among this I have to remove copper, and I need nickel. Removal of copper and subsequent isolation of nickel is what we know as purification, or you can say that refining, or you can say that is a purification of metal. This is what the step. This is the refining and purification of this matte. Refining and purification of matte was done by many processes. Like we have Mond's process, we have electrolytic process, we have Oxford process, I think we have German process. These are the several processes what we have for the for refining of metal. Refining in the sense what? Removal of this copper and isolation of this nickel. Removal of this copper and isolation of this nickel. And I am going to select Mond's process for explanation purpose. Especially this is the process which is widely used, and in the examination perspective it is very important. That's why I am selecting that Mond's process for the explanation, right? Now we will come to know Mond's process. That Mond's process involves several steps, right? That Mond's process, and this Mond's process will involve several steps. And as per the Mond process concept, the first step is roasting. After Bessemerization, you have Bessemerized mixture, right? Bessemerized mixture. That Bessemerized mixture contains what? Nickel sulfide and copper sulfide. When you roast that Bessemerized mixture, what you are going to get? The sulfides of nickel and copper gets oxidized and leads to the formation of respective oxide. That is, your nickel sulfide combines with oxygen will lead to the formation of nickel oxide plus SiO2, right? And your what? Copper sulfide will combines with oxygen will lead to the formation of what? Copper oxide plus SO2. This is the reaction what you are going to observe in roasting of Mond's process. After getting your respective oxides, you have a mixture of oxides. And second step, what you have to do is leaching. That means, why I have to leach? Why I have to use the leaching process? You have a mixture of nickel oxide and copper oxide. Leaching is nothing but it is one of the method of concentration. It is a chemical method of concentration where you are going to use solvents to concentrate your desired material. And your desired material is nickel. You want to concentrate your nickel. For that you are going to use some solvent. And in this case, in this leaching process, I am going to use a solvent, a 15% of sulfuric acid. 15% of sulfuric acid. When I mix, that means when I treat this mixed oxide mixture to this 50% of sulfuric acid, I am going to observe a reaction that is what? That is copper sulfide, 15% of what? This sulfuric acid at 353 Kelvin temperature. Temperatures are very important in this metallurgy. because all the reactions all depends on temperature. If you know about the chemical kinetics, right? You know, you are going to observe that copper sulfate plus H2O. That means your copper oxide gets dissolved as copper sulfate, but your nickel oxide in this remains as residue. Remains as residue or solid. It remains as solid mass or residue. Your nickel oxide remains as residue or a solid mass, but your what? A copper oxide gets dissolved as a copper sulfate. Now you have a solution. That solution contains a solid mass, which is nickel oxide, and a liquid, which is a copper sulfate. Then how you are going to separate? By simple method, by simple process, that is called filtration. Through filtration, you can separate this copper sulfate and nickel oxide. After filtration, you will come with you will become successful in removing that nickel oxide. In removing what? Nickel oxide. Right. This is second step. After leaching, the third step involved in the Mond process is what? We have a nickel oxide. If I remove the oxygen from that, I will get nickel. How the right? From that nickel oxide. If I remove oxygen from that nickel, I will left with oxygen. I will be left with a crude nickel. So for that, what I have to do? The process is what known as reduction. Removal of oxygen is nothing but what? Reduction. And the reduction of nickel oxide was done by a gas, that is what? Water gas. Reduction of nickel oxide was done by water gas, and that too at a temperature 223 to 333 Kelvin. At this temperature, this nickel oxide combines with oxygen will give, or carbon monoxide will give nickel plus CO2. At the same time, this combines with H2 will gives Ni plus H2O. These are the two reactions what you are going to observe in reduction of Mond's process. Here, the nickel oxide combines with carbon monoxide will give you a crude nickel. Here at the same time, this is what a reduction of nickel by using water gas at this temperature. Right? Reduction of nickel oxide by using water gas at this temperature. After reduction, you are left with a crude nickel. Crude nickel is about an impure nickel. So to make that into pure, that nickel containing a volatile impurities after that reduction. So that we have another step, that is our first volatilization. In volatilization, you know, the nickel which is obtained after reduction, I will make this nickel to combine with carbon monoxide to the formation of nickel at this. And this is about temperature about 50 degrees Celsius. At 50 degrees Celsius, this nickel, I made this nickel to combine with this carbon monoxide, and that will lead to the formation of volatile nickel carbonyl. Right? In this volatilization, you are going to form volatile nickel carbonyl, and I am going to make a decomposition. Decomposition is nothing but this nickel carbonyl at a specific temperature like 180 degrees Celsius. At 180 degrees Celsius, I am going to heat this at 180 degrees Celsius. The volatile impurities gets evaporated. And pure nickel gets deposited. This is pure nickel, and percentage about 99.8%. Pure nickel we will obtain through Mond's process after decomposition. After decomposition, you will get about 99.8% of pure nickel. And the carbon monoxide, what you obtain after decomposition, will make use of for the volatilization reaction. For volatilization, this is what after this Mond's process, you will get a 99.8% of pure nickel. And this is what the several steps which are involved in the extraction of nickel. Right? And thank you for watching this video. And please support and share